Okay, if we look at example 5a up on the board, it says solve 25 equals 10 to the x minus 1 power, round answer to the nearest thousandth. First off, you're going to notice this has a similar structure to what we've been seeing here with these exponential functions. We have a functional, or an exponential expression over here equal to a number, and our technique so far has been to get the bases to be the same number. So this is 10 to a power, 10 to the first is 10, 10 to the second is 100, 10 to the third is 1,000. It skips over 25, right? So 10 to the first 10, 10 to the second 100, 25 doesn't get hit by that plan. And I can't break down 10 to some number to a power smaller than 10, it's 2 times 5, right? This has a 5 in it, but that 2 is still there, just creating havoc, so yes.
Is that x minus 1 or x?
It's the x minus 1 power, so
Okay.
10, and then x minus 1 is all up in the power.
I don't know if it's x negative 1, but
No,
then I would have had negative 1 then.
No, it's x minus, so it's an algebraic expression, x minus 1. And sometimes, a lot of times we've been seeing x's up there, right? But again, it can be any algebraic expression up in the power as we do these, all right? Now, when this occurs, when we can't make the bases the same number, because I can't in this case. 10 to the first is 10, 10 to the second is 100, skips over 25. I can't do the technique I've been using. I want to use logarithms in order to solve this problem. And one of the rules of logarithms I'm going to use is this one here. If you have log of something to a power base something, if you have that structure. So this is what we're taking the logarithm of, and again the base doesn't matter, it can be any base whatsoever. If you have that structure, you are legally allowed to pull the power out in front of the logarithm like so. So if I have a power expression like this, 10 to the x minus 1 power, and I have log of that expression, I can legally transform it into this technique here. So what I'm going to do here is I'm going to log both sides. Like so. And the base I choose is my choice. I can choose any base I want to. Let me give you some criteria for picking bases. The only two bases that your calculator has on it are base E and base 10. That's it. So if I'm picking bases, those are the only two bases I want to pick because that's what my calculator has the capacity to do. The second criteria is I don't care which one of those two I pick except when there's a 10 or an E in my problem. If there's a 10 in my problem, I want to pick 10. If there's an E in my problem, I want to pick E. All right? Or I want to pick Ln. So, in this case, since it is 10 to a power, I want to go base 10 on both of these logarithms. If I did natural log, it would still work. It just wouldn't be as pleasant because 10 and E don't interact with each other very well. So, because that's 10, I'm doing log base 10. If it said E, I would do log base E. If it said 77, it doesn't matter which one you pick. Pick one, you'll be fine. And again, something we just learned yesterday from our homework and just a moment ago as I went over the homework was when we see this picture here, this base matches that base, then this is what that evaluates to. So what I get is log of 25 base 10 should equal x minus 1. By picking log base 10, and I have 10 to a power, that's what happens. All right? So, at this point, log of 25 base 10 is something my calculator can evaluate. X minus 1 is what it equals, so all I have to do to get x equals, I have to move the 1 over here, right? I'm going to evaluate this first. It says to the nearest thousandth. I'm going to go 4 decimal places in my work, round my final answer to 3, which is the thousandths place. Again, we have calculators that you have available to you, these calculators here. Okay, I'm going to use my board calculator just to...
So would that make it 25 and 6?
This is log of 25, and if it's log of 25 plus 1, Log of 25 is its own
Oh,
object that
okay.
has to be evaluated. The plus one happens after the log happens.
Oh, okay.
Right? So, if I go to my calculator and type in log, it's LOG because I did base 10, 25. It's 1.3979. And evaluate the logarithm first, and then solve for x by moving the 1 to the other side. So it's going to be plus 1. So I get 2.3979 equals x. It does say round answer to the nearest thousandth. Again, I kept my work to 4 decimal places. The thousandths place is the 3rd decimal place, and the 4th digit's a 9. So since the 9 is bigger than 5, we're going to go up. So the correct answer to the nearest thousandth is 2.398. If I go back to the original problem, if I replace x with 2.398, and I punch it in a calculator, 2.398 minus 1 is 1.398, right? So if I do 10 raised to the 1.398 power, it should be close to 25. Again, we rounded, so it won't be exactly right, but it should be pretty close. And 25.0035 is pretty close. Yes?
So, so the base 10 and the number 10, that just equals 10 on log 1025 down there because it matches?
You have to log both sides.
Yeah.
And you have to log both sides to the same base. I chose base 10 because that matched that, and when those match, this side just becomes the power, and this becomes whatever base log I had to do to make that happen.
Oh, okay.
So if I had the same, let me give you a different problem that looks like that. Suppose I gave you this. 25 equals e to the x minus 1. Right? So this time I can log both sides again, so I'm going to do log of 25 equals log of e to the x minus 1, right? This time the base is e, so I'm going to go e. And log base e is natural log, right? So natural log of 25 equals x minus 1. Again, because this matches this, that side just becomes the power.
Okay.
All right, so again, you log both sides, same base. You choose the base, either e or 10. That's what you have to do, all right? And then again, now I'm going to do natural log of 25 instead of log of 25. Natural log of 25, that equals 3.2189.
And so, like, you know how in the other one you brought 10 down with that new problem? Yeah.
I brought e down, log base e is the same as ln.
Okay.
So again, when I see this and I need to use a calculator, I'm going to transform it into what the calculator button looks like.
Okay.
Log base e means natural log. So they mean the same thing. So I didn't, like, log base 10 is log base. I think really the calculator button is just log, right? So I really could
Yeah.
left the 10 off if I wanted to. But again, I didn't see any harm in leaving the base on there. But I could have left it log base c also, just know that it's ln on your calculator. All right? And then if you move the one over here, x equals 4.2189, which would be 4.219 rounded to 3 decimal places. And notice if I grab my calculator now and I raise e to that power, so second e to the, it's this minus 1, so it'd be 3.219. Again, we rounded, it won't be exactly 25, it should be pretty close. All right, so again, either ln or log. If it's base 10, use log base 10. If it's e, use ln. If it's anything else, doesn't matter what you use. I usually go with ln every time. ln is 2 letters, log is 3 letters. I have to write less that way, so that's how I make my decision.